Welcome everybody to Practical Numerical Methods for Scientists and Engineers. Today we are still in Module 4, Roots of Equation, System of Equations, and here we have Gauss-Seidel method. Gauss-Seidel method is considered as iterative method, so we use it to find roots of a system of linear equation. The condition that it should be non-zero and it's better to be diagonally predominant. That means the diagonal has a maximum vectors, larger value of vectors. So if so, then the first equation can be solved for x1, and the second equation can be solved for x2, and third equation can be solved for x3, and so on. And then we can start the iteration by considering all zeros, okay, and then we can substitute x1, and we can use the recent calculated x to be substituted in the other x. We will see how to perform this. So for example, we have this equation, okay, and we will suppose that they are predominant, so we can solve the first one for x1, second one for x2, and third one for x3. Okay, now for example, if you are given equations that are not predominant, for example 2 here is less than 5 and 2 is also small, but if we did some rearrangement, like for example we put second equation in the first one, so and then check this one, we put it here, second one, so the equation now become predominant, so we can solve it. It will give better results, so x1, x2, and x3, so we can solve and start our iteration. So here we can make a table and put x1, x2, and x3, and then x2 we can solve the x2 based on x2 and x3. Since all are 0, so we'll put them 0 to find x2. Now this x1 becomes the most recent values, so x2 need x1 and x3, so we'll put x1 here, okay, and put the x3 as a 0, and then x0 needs x1 and x2. Since the recent values are these, so we'll put them here, substituted here, and found x3. Again, we can use for this one is we'll repeat the second, third iteration, fourth iteration, fifth iteration in similar way. Then we can calculate the relative error as x new minus x all over x new. And since the first one is we didn't calculate for first iteration, we can't calculate because we don't have the previous one. Second one, of course, it will be the maximum 100%, but as we go further with iteration, the relative error becomes smaller and smaller and smaller. Now we can do it easily by calculations, but we want to find a way to solve it using Matlab. So in Matlab, we have to do some rearrange of the equation to be solved. So now suppose that this is my equation, okay, first equation, second equation, third equation. Matlab is better to solve this equation in terms of matrices. So in order to form matrices, we can divide each item by A11 or A22 or A33. So here's it will become like this, okay. Then we can here we can say x1, x2, x3 equal, we can call this D, okay, and then these two parts are another matrix, okay. So this one is vector or array, and this one is a matrix. But as you can see here, we don't have the first row, we don't have x1, the second row we don't have x2, and the third one we didn't have x3. So we can create a matrix diagonally 0, okay, and here put x2 and x3. Here's x1, x2, here's x1 and x2, and we don't have x3, and all of them multiplied by x1, x2, x3. So we can get this equation. Now it's become applicable to be formatted in Matlab. X equal d minus c times x. Now, how to perform it using Matlab? Now, we said we have two options. The first option, the matrix should be squared. It's very important to solve the equation. The second is it is recommended to have diagonally predominant. Okay, so now we want to apply these two conditions to check. So first we have input. We put the inputs matrix, and then we put the right hand vectors, and then you can put your relative error and maximum iteration. Now, in order to check the matrix is it square or not, like before we created m and n equal the size of the a, and in case of m doesn't equal n, then it gives error, matrix a must be square, end. Now we want to check if the matrix A is diagonally predominant or not. So now we have different x, so from until n. So you want to check each row. We want to check each row if each row is predominant or not. Okay. So what we should, in order to do this first item A11 should be larger than the A22 and A33. So in another way, we can, if we check if A11 larger than both or the summation of both A12 and A13, then it will be predominant. And if A22 is larger than summation of both A21 and 23, then it's predominant, and so on for the A33. So how to create it? Okay, now we used for I equal 1 to n, so j equal 1 to n as well, and then we gi equal if you remember, we use this squared bracket to remove the element, and then b equal abs a I j, and then we can. So how let's take one example just to because I know it's a little bit confusion for you, so let's describe. So now I equal 1 to n. So we'll start from, suppose that we have three trials, 1, 2, and 3. So let's start with 3. So let's start with I equal 1. Okay, I equal 1. Okay, for the first trial, j will be 1 to 3. So j will be 1, 2, 3. Then we cancelled ji equal empty. Okay, so that means this we have j, so we want to extract I is here 1, so it will be, then j will be only 2 and 3. Okay, perfect. So here we have I equal 1 and j equal 2 and 3. Now we created b, and b is absolute value of a, I and j. So what's a and I and j? I here is the first row and j is the second and third column. Okay, so for this, okay, so we extracted both vectors, this one and this one. Okay, now we created like equation check. We call this equation, we call it check I equal abs, okay, I extract I, so I extracted the first value, this one, minus summation b. B is 2, so I combine them together, so this one minus 2 values. Okay, so if if this equation is less than 0, that means abs I is less than the summation, so it shouldn't be predominant. Okay, then show this finger if printf the matrix is not structurally diagonally dominant at row I. Okay, so here you have the option to continue or to stop. Okay, so here I put k input, I put one message. Okay, k equal input. If you want to stop, please press 0, and I put condition. If k condition 0 equal 0, then return, so to start again, else continue until and end and end. Okay, we have end for if and end for the for. It's okay. I know maybe it's a little bit complicated, but please revise what I did again and try to like what I did here. Try to make it by your hand to closely understand how the logic works. Okay, now we can start now to make the method, iteration method. So first I want to create C. So C is exactly equal to A, but it's divided by the first one for each row, and the first vector become 0, coefficient becomes 0. So it's only C is A, but it's a little bit different than A in that it is diagonally 0, plus for each row it's divided by the coefficient of the number of row. So how to perform this? Okay, now I created C equal A, so I created C that is equal to matrix A exactly. So we copied another matrix of A, okay, in order to keep the original one untouched. Okay, then I created, okay, X equal, I want to create X here, equal N1, zeros N1. So what's N? N is the number of rows and one column. Okay, so X will be like this, 1, 1, 1. Okay, now let's start. For I equal from 1 to N, okay, here we want to convert the diagonal of matrix C to 0. We created matrix C, we want to convert the diagonal to 0. So how to make it? Then C I equal 0. So here for each one I, that means the first one becomes 0, then it will go for 2 2, it becomes 0, then it becomes for 3 3 becomes 0. By this we converted all to 0. Okay, but still we didn't divide. Okay, now we want to how to make from I, okay, from I equal 1 to N, then C from C the I until 1 to N, I is number of row until 1 to N for all rows, okay, equal C from I 1 to N divided by I. So by this I converted all matrix to the final end. Okay, now we want to get vector D. So now we created vector C, done. We want to get vector D. What is vector D? It's B. So B is a final, it is a V is a coefficient right hand vector divided by I 1 1. So it's easy, from I equal 1 to N, Di equal Bi divided by Ai. Done. Now we converted D. Okay, so then we can start the iteration. Now it's become easily. So iteration equal 0, while 1 we should define x alt, okay, like we did before, x alt equal x. Then for I equal 1 to n, xi to extract I, to extract the same row, equal d minus c xi for all rows times x. If xi not 0, then error, okay, absolute and error abs equal, find the error message equal abs xi minus x all over I times 10 end. Then iteration equal iteration plus 1 if maximum error, okay, so maximum error less or below the iteration or iteration larger than iteration, then break end. So here, okay, by this we find the iteration. So I think now it's become more clear. I don't think I can make it easier than this. So hope you understand it, and if you have any question, please you can write comments. So see you in next session. Thank you.